In today's video, we're going to talk about how to solve a system using substitution. The substitution method is the best way to solve a system when one equation has one variable by itself, and that can be either x or y. Okay, so if I take a look at these three examples, it says determine whether or not the following equation is set up for substitution. So if I look at these two, I have 7x minus 8y equals negative 9. Neither of those variables are by themselves. However, in this equation, I have y equals 10x minus 1. That y is by itself. It's alone on one side of the equation, and it doesn't have any coefficient. So y is by itself. So this equation, this system of equations, is set up well for substitution, and y is the variable by itself. If I look at example 2, in this first equation, I have x equals 2y plus 3, and x is already by itself, so this is set up pretty well for substitution. There's x, so x is equal to 2y plus 3, and then here I have 4x plus 5y equals 6, and that doesn't have either of the variables by themselves. So this one is set up pretty well to solve substitution-wise using x. And then in this third equation, I have 7x plus 8y equals 9, and 10x minus y equals 2. Neither of these variables, x or y, are by themselves in either equation, so the answer to this system, this one's no. It's not really well set up to use substitution. All right, so steps. Identify the variable that's by itself in one of the equations. Circle this variable in the other equation. So in this equation right here, I have y equals 7x minus 3. So y is by itself right here. And instead of circling, I'm going to use highlighting. I think it'll be a little bit easier for you to see. So in the other equation, y is right here. So we want to somehow identify it. You can circle it or highlight it. Again, I'm going to highlight just because I think it makes the visual a little bit clearer. So step 2 is to substitute the circled variable with one expression in the other equation. Make sure to use parentheses when substituting. So that might sound a little bit confusing. So basically what you do is you know that y is equal to 7x minus 3. So I'm going to replace this y with this expression. So that's the substitution property. Y and 7x minus 3 are equal to each other. So I can replace y in this equation with 7x minus 3. So if I have 10x plus 3y is equal to 6, I'm going to replace y with 7x minus 3. So 10x plus 3 times 7x minus 3 is equal to 6. Okay, so what this allows me to do now, I've gone from having two different variables to only having x's by using that substitution property of equality. Okay, so one more time, you can see I've replaced y right here with 7x minus 3 in two different equivalent expressions. All right, step number 3, solve for the remaining variable. Be sure to use the distributive property correctly. So I have a multi-step equation that looks like this. So in order to solve that, my first step would be to use the distributive property. So I have 10x plus 3 times 7x gives me 21x minus 3 times 3 is 9. All right, first step would be to combine like terms. 10x and 21x gives me 31x. Okay, and then from there, I would want to add 9 to both sides. And when I've added 9 to both sides, that leaves me with 31x is equal to 6 plus 9, which is 15. I'm going to come up here, running out of room, so I have 31x is equal to 15. And in order to solve that, I would divide both sides by 31, which gives me x is equal to 15 over 31, which I do not believe can be simplified. So x is 15 over 31. Okay, stand up up a little bit here. All right, step 4, substitute the first value into one of the original equations. Remember, the solution to the system is always an ordered pair. So we know what x is, we now have to find y. So it would be a lot easier to take this x value and substitute it back in for x here in order to find the y. So you pick whichever equation is easier. In this case, it's easier to plug in to the second equation. So I'm going to have y is equal to 7 times 15 over 31 minus 3. So to multiply the fractions together, I'm going to have to put the 7 over the 1. And that's going to give me y is equal to 7 times 15, which is 105, over 31, 1 times 31, minus 3. Come up here and make a little bit more space. Okay, common denominator. So y is equal to 105 over 31 minus 1 times 3 gives me 93 over 31. Again, I have to have a common denominator in order to subtract. So 105 minus 93 gives me 12 over 31. Which means my ordered pair, x comma y, so I have 15 over 31 comma 12 over 31. All right, a couple more examples. All right, so first step I have to do here is figure out which equation is solved for the variable. In this case, the first one, solve for y, and then I identify y in the second equation. So I'm going to replace this y with this expression. So I have 3x plus 4 times x plus 2, and that's still equal to 5. And I'm going to use my distributive property, so I'm going to distribute the 4 to both pieces. So I have 3x plus 4x plus 8 is equal to 5. Combine my like terms, 3 plus 4 is 7x. Right, then I'm going to need to subtract 8 from both sides. So that gives me 7x is equal to 5 minus 8, which is negative 3. Dividing both sides by 7, I end up with x is equal to negative 3/7. So now I know what x is. I need to go back and I need to find y. So I'm going to take my x value, I'm going to plug it back into this equation right here. It's the easier one to use. Y is equal to negative 3/7 plus 2. Need a common denominator to add, so y is equal to negative 3/7 plus 14/7. If I add those two fractions together, I end up with y is equal to negative 3 plus 14 is 11 over 7. So I have my x value and my y value, meaning that my final ordered pair would be negative 3/7, 11/7 as my final answer. All right, last example. If I take a look at these two equations, right here, this one here is solve for x, so that's the first equation. And then if I highlight in the second equation, I have an x right here, so I'm going to replace. So I'm going to take this expression, 4y plus 5, and I'm going to plug it in for x over here. So I have 4y plus 5 minus 2y is equal to 3. So again, that expression right here is going in for x right there. No distributive property this time. I have 4y plus 5 minus 2y equals 3. All right. Combining like terms, 4y minus 2y is 2y plus 5 equal to 3. And then in order to solve this, I need to subtract 5 from both sides of the equation. And I have 2y is equal to negative 2. Divide both sides by 2. And I end up with y equals negative 1. All right, now I know what y is, so I have to go back and find x. It's easier to use the equation that's already solved for the variable I'm looking for. So I'm going to have x is equal to 4y plus 5. But we know y is negative 1. So I'm going to use substitution again. 4 times negative 1 plus 5. And then I can simplify. X is equal to negative 4 plus 5. And negative 4 plus 5 is 1. And then finally I have to write my ordered pair. Remember, x always goes first. So I'm going to have 1, comma, negative 1 as my final ordered pair.